Hello, in this video I will integrate partial fraction with a linear and a repeating quadratic. So we have a linear, x plus 2 is the linear, and then we have a repeating quadratic. So let's first decompose this fraction. Okay, so x plus 2 will be a over x plus 2, x squared plus 3 squared. That is a repeating quadratic, so we're going to break it up into two sections. So it would be bx plus c. And then the last one would be dx plus e of x squared plus 3 squared. So remember how we said the power on the bottom always has to be bigger than the top. So this one is good, and you don't need a c, you don't need a constant over here. This is a power of 1, and we do need a constant. And then over here, it's the inner power. So this is the power 2. So this is power 2. So yes, we have a 2, and then we have a 1, and then yes. Now we got to find A, B, D, and E. Okay, so we're going to do it by multiplying all three sides by the LCD. So my LCD is x plus 2, x squared plus 3 squared, and then multiply all three sides by that. Okay, so on the left, what do you see that cancels? The numerator. Everything else cancels, right? Okay, on the right, so if you multiply this, the x plus 2 cancels, so you're just left with A. Over here, what do you see that cancels? Uh, just one of the x squared plus 3. So you're left with, so you're left with the x plus 2, and then this cancels, so you're just left with 1. And then over here, the x squared plus 3 squared cancels, so you're left with dx plus e times x plus 2. Okay, now what you would do is kind of like FOIL it out. So let's do, I know it is a pain. So a times x squared plus 3 squared. So when you FOIL that out, that would be x4 plus 6x squared plus 9. And then when you FOIL this, uh, here, then FOIL out the a, so that would be ax4 plus 6ax squared plus 9a. And then when you FOIL this whole thing out, you're gonna get, I'm just gonna write it out. It's gonna be bx4 plus 3b x squared plus 2b x cubed. And then, so basically when you FOIL this out, all of that out, you're gonna get this. Yeah, it is a pain. So if you FOIL this out, this is what all you get. Okay, then what you have to do is kind of like collect like terms. So the left stays the left, has not changed. The right, so what you want to do is start with the highest power and okay, so our start with the highest power. So go circle box or anything with the power 4. So you have in the power 4 you have ax4 plus bx4, and then you're next left with 2b cubed, 2b x cubed plus cx cubed. The next one is 6 6ax squared plus 3b x squared plus 2c x squared. And then you're left with 6 bx plus 3cx plus 2dx plus ex plus 6e and 2e. So then you just line them up. So this thing right here lines up with 3x4 because they're both to the, so you're gonna set it up as a system of equation. So it's gonna be 3x4 equals to ax4 plus bx to the fourth. Then you're this 2b cubed cx cubed is related to 4x cubed. So I could put like a little comma. So it'll be like 4x cubed 2bx cubed plus cx cubed. The next one is x squared. So you have this is related to this 16x squared. And then x's 20x is related to what is it? 20x is related to this whole thing, cbx, 3cx, 2dx, and ex. And then finally, the constant is 9 equals 9 equals 9a 6c. Oops. So 9 equals, so the constant equals to 9a plus 6c plus 2e. Okay. And then what we're going to do is, what can we do? Uh, on this system equation, I can get rid of the x4. So I would have to divide everything by x4. So you have 3 equals a plus b. And then over here, you could divide everything by x cubed. So that's 4 equals, and then over here, you can get rid of the x squares by dividing everything by x squares, right? And then over here, you could divide each term by x. And over here, this just stays the same. So what can I do next? Let me write out my system of equation better because it's all over the place. So our first system equation is this. So you could say a plus b equals to 3. The next one is this thing. So I could rewrite it as 2b plus c equals to 4. The next one is this. Okay. The next one is this one right here. So that's 9a. Okay. So what can I do? If a plus b equals 3, what can I do? So maybe if I said substitution, what if I let a equals to 1? That means b must equal to 2, right? Because yeah, I think if you solve for a, it would be 3 minus b, or if I solve for b, I would get b equals to 3 minus a, right? So uh, yeah, so I'm gonna set a equals 1 and b equals 2, and I think I could solve for c now, because that would be 2 times 2 plus c equals to 4. So that's 4 plus c, just 4, and then solve for c So C equals 0. And then over here, if my A is 1, if my B is 2, it would be 6 times 1 plus 3 times 2 plus 2 times 0 plus D equals 16. So that's 6 plus 6 plus 0 plus D plus I don't know what D is, right? So 6 plus 6 is 12 plus D equals 16. Subtract 12. 16 minus 2 is 14. 4. So D is 4. Can I figure out what my E is now? Yes. So I'll put it into this equation. So it would be 9 times 1 plus 6 times C plus 2 times E, which is, what did I say E was? I'm not sure. Let's find that out. So that would be 9. 2E equals 9, so this would be 0. So you have 2E. Wait, no, sorry. 9 times 1 is 9. 6 times 0 is 0. That's 0. Plus 2E equals 9. Solve for E, so I would subtract 9 from both sides. You get 2E equals to 0. Divide this by 2. Equals to 0. Okay, and then now we have our A. 1, my B is 2, my C is 0, my E equals 0, my D equals to 4. So this would be so if we set so our A, so we're going to set it up like here. So that would be simplified as 1 over x plus 2 plus 2x over x squared plus 3 plus 4x over x squared plus 3 squared dx. Okay, so what I could do is integrate each one at a time. So over here, 1 over x plus 2, you can use u substitution. So that would be u equals x plus 2. Du would be 1 dx. So this would be 1 over u du, which is what's the integration 1 over u ln of absolute value of u, so it's x plus 2. Over here, I would use u as x squared plus 3. So my du would be 2x dx. And it comes out nicely because we don't have to get rid of anything. So it's going to be 1 over u, and then you're going to replace 2x dx with du. So that would be ln of absolute value u, which is x squared plus 3. Over here, this would be, my u would be x squared plus 3. My du would be 2x. Wait, hold on. Is there anything I can do before I do my u substitution? Yes, I can take out my 4. So u is going to be x squared plus 3. Du is 2x dx. Now this time we can get rid of this 2. So I'm going to get rid of that 2 by multiplying it by 1/2. So 2 times 1/2 is x dx. And then this would be u squared, because our u is x squared plus 3. And then my x dx is 1/2 du. Take out this 1/2. This is 4 times 1/2 over 1 over u squared du. 4 times 1/2 is 2. 1 over u squared is u to the negative 2 du. And the integration of u to the negative 2 is negative 2 plus 1 is negative 1. So that times it by 2. So that's negative 2, u to the negative 1 is 1 over u. So that is negative 2 over u, which is my u is x squared plus 3. And then over here, you're just left with ln of x, ln of absolute value of x plus 2 plus ln of x squared plus 3. And then minus 2 over x squared plus 3, and then plus c. Final answer. Okay, that wraps it up for this section. So